Assalamu alaikum and welcome back, guys. I believe that I have told you all the required things to solve the past paper questions on the connected particles. Okay, so I have a question from November 10, variant 41's last question. That is the question number 7. It's a 10 marks question. Okay, so it looks like this question over here. Okay, and I have just copied its diagram over here. Now let me read the statement. It says the particles P and a Q of mass is 0.2 kg. So I'm going to right away show its weight as 2 newtons, and this is the Q over here, its mass is 0.5 kg. Okay, so this is going to be 5 newtons. Okay, are connected by a light and extensible string. The string passes over a smooth pulley at the edge of a rough horizontal table. Okay, so this table is horizontal. This this is a rough horizontal surface over here. Okay, now it says P hangs freely and Q is in contact with the table. A force of magnitude 3.2 newtons over here. You can see that this is the 3.2 Newton force. Okay, and this is acting upward from this horizontal level at an angle of 30 degrees. Okay, so it says the system is in limiting equilibrium, guys. Remember the limiting equilibrium. So when we say there is a limiting equilibrium, so you should immediately have the limiting friction in your mind. Okay, so that means right now the limiting friction is in action. The maximum possible friction is here. Okay, so it says find the coefficient of friction between Q and the table. Now there are 6 marks for this. Okay, so now let me show this tension upward over here, and here is the tension. Okay, and we should resolve this force, this upward force. This is 3.2 cos 30, this is 3.2 sine 30, and here is the R to be shown. Okay, now 6 marks, guys. Okay, so we have to find the coefficient of friction. Now first of all, by looking at this P, we can say that the tension in the string is right away 2 newtons. Okay, so like equilibrium situation, so this tension is 2 newtons. Okay, and then now it doesn't tell us that if it is in limiting equilibrium, so this particle Q or the particle P, like particle Q, is it about to move towards the pulley or away from the pulley? Or if we look at this particle P, if this P is about to move upward or move downward. Okay, so we are not given anything. It says, yeah, with P about to move upwards. Okay, so P is about to move upwards. That means this Q is about to move towards the right side, away from the pulley. So that means the frictional force would be in this direction. Okay, now for example, suppose it was not given to us that in which direction they are about to move, then you could have kept this X in any direction. Okay, and then the sign of this X, for example, if you had put this X in this direction, so then you could have got this X as negative. So that would like, correct your mistake. So you can change that direction because of that minus sign coming in your answer. Okay, so now we know that this is about to move, P is about to move up, so Q is about to move towards the right, so the frictional force has to be towards the left. Okay, so now if we look at this Q, so we have this, by looking at this Q, like, the horizontal forces, we have T plus X, that is equal to 3.2 cos 30. Okay, we have already got the value of T, and then this is going to be, this X is going to be, let me keep it exact. Okay, 3.2 cos 30 and minus this 2. Okay, now if we look at this, the vertical components over here, so we can determine this R over here. Okay, so this R plus this 3.2 sine 30, that will be equal to 5. Okay, so that is how you will determine this R plus 3.2 sine 30, that is equal to 5. Okay, we know that sine 30 is half. Okay, so this is going to be, R is going to be 5 minus 1.6, So this is 3.4 newtons. Okay, so we have its exact value. Okay, now we have to find the mu, the coefficient of friction. Okay, so for that we know that x is equal to mu r. Okay, x is equal to mu r. So mu is, x is 3.2 cos 30 minus 2 and divided by r, which is 3.4. So that this will give you the mu. Okay, so we have this coefficient of friction calculated 0.227. Now moving towards the second part. Now this was, there were like 6 marks for all this working. Now moving to the second part, it says the force of magnitude 3.2 Newton is now removed. Oh, so we're just going to remove this force. Okay, so and P starts to move downwards. Okay, this P is moving downwards. So now we have to find the acceleration of the particles and the tension in the string. Okay, so when this this inclined force, this 3.2 Newton force has been removed, so guys, this is going to change the whole situation. First of all, R will change. When R changes, the frictional force will change. Okay, so this is a very common mistake, people using the same frictional force in the upcoming parts. Okay, when the situation changes, you need to assess the things very carefully and then do the things accordingly. Okay, so now we're given that this P is going to move downwards. That would mean now this frictional force would be acting towards this side. Okay, so since this particle Q and this surface is same, so this mu can still be used. Okay, but for the second part, R is simply going to be 5 now. Okay, when your R is 5, you will recalculate the frictional force, that is mu is 0.227 times 5. Okay, so I have its exact answer here, so I'm just going to do that times 5. So this frictional force is going to be I'm just going to write this as much as I can write it. Okay, so this is the frictional force over here. Okay, and now this is the that typical situation where these two particles are now moving. Okay, this is moving downwards, this is moving horizontally. So we shall have those two equations through that F equal to ma, and we shall be solving them simultaneously to get to the acceleration and the tension in the string. So now by looking at P is moving downwards. So now I can say that downward is a weight, upward is a T, and that is equal to 0.2a. That is the first equation. And by looking at Q, we have the Q is moving towards the pulley, and this is the force resisting this motion. So we have T minus this 1.134237, that is equal to 0.5a. Okay guys, if you solve these two equations simultaneously, you will be able to get the tension in the string and the acceleration. Okay, in the next video I'll be coming up with a bit harder question on connected particles, and that should be the last video on these connected particles. Okay, so if you require any other question solution, just tell me, I'll make a video for that for you. Okay, Allah Hafiz.